Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 22 in chapter 18. Chapter 18 is about kinetic energy of gases. So there, we start from Maxwell distribution of speeds and then need to prove these two equations, right? So first one, we can write down the Maxwell distribution of speeds. Look like this one. Agree? And then we need to prove the part 1. Part 1 is the integral Fv with dv. So we write it. We input this Fv inside. So this part is called Fv, right? And this part is dv. Now you can see in this term it's constant. It has no terms called v, right? So this term constant 4 pi n, this term bracket, and then 3/2. We can put it out. And then we can write it as v square e negative r negative this term v square. And to simplify, we write the alpha as m over 2kt to replace it, right? So it becomes negative alpha v square dv. And when you do this integral, yeah, you can do this integral by yourself, right? Integral by part. But there, I suggest you look at the mathematical handbook. If you check the mathematical handbook, you will find the solution for this function. So easy, right? So this one, you can just directly write it as squared pi over 16 alpha cube. You directly write it as there. See? Now things become so easy. You input alpha back, you record the alpha back at there, and then do some organization, get the final answer there. The next one, we need to look at this function, right? This function is v times v squared Fv dv divided by n. Still same thing, we input Fv inside. So we input the Fv inside and write v squared and then v squared at there. And e, this one divided by n. You can see n cancels, right? And it's a 4 pi, this bracket 3/2 constant. It has nothing to do with v, so put it out. Then this integral looks so simple, right? It becomes v 4 times e negative alpha v squared dv, right? There we let alpha equal to m over 2kt. So it looks like we need to do the integral by this one. A little bit difficult, right? Still, I suggest you to check the handbook, to check the mathematical handbook. And then you can see we have the mathematical handbook look like this one. The most similar one, but it's not the same thing because there is alpha, right? So how can you do that? There, we need to satisfy negative alpha square, so we can let this alpha v square equal to x square. Agree? Equal to x square, so which makes the v equal to alpha over squared alpha. So from this one, you can get this one, and then we take the positive part, and so dv equal to dx divided by squared alpha. Right, now we input it back. So in this case, the v first, the power 4 becomes what? Becomes x power 4 over alpha squared, right? So this we input it back. And then we get e negative alpha v squared becomes e negative x squared, and dv as dx divided by squared alpha. It is close to this term, agree? It is close. Now we take these terms out. So we take the 1 over alpha squared and 1 over squared alpha out. And this one looks like exactly same as this mathematical handbook. Agree? And then we input the answer for this integral and reorganize these terms, get the final answer there. Thank you.